So today we are essentially reviewing all the integration techniques you know so far, and I'm going to mix them up and show you how they can be made complicated because they look a lot alike, but they're not exactly the same, and you have to recognize the differences. So let's write down 4 integrals that we're going to integrate, and they all have the same denominator, but they are very different results. So the first one, is going to be, actually I'll circle it, the integral of 4 over x squared plus 9 dx. And my second integral that I'm going to do is the integral of 4x over x squared plus 9 dx. And my next one is going to be the integral of 4x squared over x squared plus 9 dx. And my last one is going to be the integral of 4x plus 4 over x squared plus 9 dx. All the same denominator. Can be easily confused because the denominator are all different technique for each one. Okay, let's start with the first one, looking at it. Just if you were going to look at it, what do you think that one looks like that you've done recently? Inverse tangent. So this one's inverse tangent. None of the rest of you remember it. This is a squared. This is u squared. That's just a coefficient. So let's do a real fast. So for a, we have that a is equal to 3, u is equal to x. The derivative of x is just 1. So I just have a 4 out in front. So that integral is going to be, so the integral of 4 over x squared plus 9 dx is equal to 4, that coefficient. Since it's inverse tangent, it's 1 over the a. The a is 3, so it's 4/3. Oh God, I can't even write. I can talk, but I can't write. 4/3 tangent inverse of x over 3 plus c. That easy? It is. If you remember your formulas. Ha 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 ha. Yeah, I know. Wow. Okay, for the next one, for b. Looking at b, do you see that that is almost the derivative of x squared? And in fact, if I factor out a 2 out of this, would I have 2x and that would be the derivative? The whole point though is, all you need to see is that if you have x squared in the denominator and you have an x on top, doesn't matter what the coefficient is, can you do u sub? That's u. So for b, we have u equals to x squared plus 9. What's du equal? 2x dx. So when I do my substitution into it, I'm going to get the integral, pull 4 out in front, right? And I'm going to have 1 over u, and then I'm going to have a 2x, but hang on, I would divide by the 2. Hang on, I forgot to do that. I forgot to solve for it. Is right here is x dx equal to 1/2 du. So that means I pull the half out in front and I have a du. So that means I have 2 natural log absolute value of, what was my u? X squared plus 9 plus c. Yeah? That was easy. Where's the button? Oh, there we go.
C'est simple.
Yeah?
What's that?
It's simple. C'est simple. Same as, it's easy. All right, for our number C. For C, let's look at C. Uh-oh. They have the same order. Guess what you have to do? Long division or division. If you know synthetic division, great, do synthetic division. I'm not teaching it to you. I don't have time for this. We're just going to do long division because they're never that hard. The ones we never are never that hard and they're never that complicated, so long division works just fine. we need to break that up so that it's something we can do. So for C, we're going to do long division. We are going to divide the 4x squared by x squared plus 9. How many times is x squared going to go into 4x squared? 4. That means I have 4x squared plus 36, and I'm subtracting all that, right? This is going to cancel. I'm going to get a negative 36. What does that mean? That means this is the remainder. And it is going to equal to, that means that what's going to happen is that 4x squared over x squared plus 9 is going to equal to 4, well, hang on, minus, because it's negative. 4 minus the remainder, which is 36, over what you were dividing by. Now is that going to make it a lot easier to integrate? Oh, so what do we end up doing? We end up with the integral of 4x squared over x squared plus 9 dx is equal to the integral of 4 minus, okay, let's go ahead and break this up. 4 dx, because this is that's gonna be inverse trig, right? The integral of 4 minus 36, the integral of 1 over x squared plus 9 dx. And we've already done that once today, right? It was inverse trig. U is x, a is 3. So what's the integral of 4? 4x minus 36 over the a, which is 3, tangent inverse of x over 3 plus c. 36 divided by 3 is 12. That's all you can do to that one. Look at what you know how to do. And for our last one, D, can I break that into two fractions? I have two things on top, keep the whole thing, whole denominator. So I'm going to change this from 4x plus 4 over x squared plus 9 dx, and that is going to equal the integral of 4x over x squared plus 9 dx plus the integral of 4 over x squared plus 9 dx. Have we done both of those already today? We have. So is this going to equal to 2 natural log? And I really should have said absolute value, but I didn't say absolute value because x squared plus 9 is always positive, correct? If you wrote absolute value of x squared plus 9, would it be correct every time? But is that what it's going to look like on the AP test? If this is multiple choice, they won't do that. What they'll put is, because those people know that this is always positive, just like I know it's always positive, and they don't put the absolute value, right? They don't have to. It's always positive. Do you understand? Okay, good. And then plus 4/3 tangent inverse of x over 3 plus c. Well, that was easy. Don't you think? Do you think? Answer's no. Okay, real fast. I want to change this. No, that's fine. We need back to draw. Get rid of that. Okay, that wasn't too bad, was it? Oh, wait, there's more. Guess what? Y'all learned all this other interesting stuff that y'all didn't think y'all would ever use. And guess what? If there's anything you learned in math, this is the time you're going to use it. And if not here, then you're going to use it in college. Okay, the next thing we're going to talk about is completing the square. Yes, completing the square. Do y'all remember doing that when you did? We did it in Algebra 2, believe it or not. At least you did in my class. I don't know what y'all did in the other classes. You should have done it last year in pre-cal for conic sections. You should have learned this for the SAT because completing the square is all over the SAT. If you know how to complete the square, it makes those problems really easy on the SAT. Really. All right, completing the square is x squared plus bx plus c is equal to, well, right now this is not something that I can factor, so I'm going to force this to be a perfect square by saying x squared plus bx. I'm going to leave a parentheses, and then I'm going to put the c outside. And here's what we're going to do. We're going to force this to be a perfect square. To force that to be a perfect square, I'm going to take b, and I'm going to go to b over 2. And then to go back over here, I'm going to square b over 2. Remember that? Since I added the square of b over 2 inside the parentheses, I have to subtract it from the outside. Now that this is a perfect square, so what I taught my students was, once you have what b over 2 is, that tells you what your factors are. Because that's going to be x plus b over 2 squared, and then it's plus some constant that is c minus b over 2 squared. Works like a charm every time. And the bad part of this for you is, this is mixed with inverse trig.
Are you kidding?
No. You know how inverse trig for tangent is x squared plus b for b, plus a squared, right?
Wait, what?
It's x squared plus a squared in the denominator?
Yeah.
Yeah, well, guess what?
Is Amanda here? Maybe.
You're in the wrong classroom.
Period.
Nick, can I see who you're looking
Her
for?
schedule, I checked the schedule, it says 1764, and then she sent
This-
me over here.
This is 1762.
Yeah, I went to that one, she sent me over here. She's not in that class.
She's not in this class. I don't know. What
The
class?
schedule's messed up then.
What class is it supposed to be?
It said 1764.
But did it tell you what class it was? Not mine.
All right.
Sorry.
Don't triple check the schedule. 'Cause I didn't.
Okay.
Thank you.
You're welcome. All right, here we go. So, what does this look like when we do one? Here's our example. So, what if I want to integrate 1 over x squared plus 4x plus 13 dx? Clearly, the derivative of that's not up top, is it? It's not there. No derivative of it, so it can't be u sub yet. Not yet. Well, I'm looking at that going like, it's a quadratic. We can complete the square. So we're going to come down here, we're going to complete the square. So I have x squared plus 4x, leave a space, plus 13. I'm going to take b. b over 2 is equal to what?
2.
2. That means this is going to equal x plus 2 squared. That's what that 2 tells me. And then I'm going to go, okay, now I'm going to square it, so I'm going to add plus 2 squared is 4. Since I added 4 there, do I have to subtract 4 on the outside? What's 13 minus 4?
9.
Plus 9. Is that a perfect square also? So what does this become? It becomes the integral of 1 over x plus 2 squared plus 9 dx. I'm going to skip down here and put it down here. So I have the integral, I'm going to write it really big, 1 over x squared, sorry, x plus 2 squared plus 9 dx. So guess what my u is? U equals x plus 2. My a is equal to 3. My du is equal to dx. Can I write the inverse trig for this? Right. Which one is this one? If it's u squared plus a squared in the denominator. It's inverse tangent. So what's my a? So So this is going to equal 1/3 tangent inverse of my u, which is x plus 2 over 3 plus c.
That was easy.
If you know the technique. If you cannot complete a square, you're just going to stare at those. Good luck with that. If it's multiple choice, you might be able to work backwards, but it's going to take you so long that you're going to miss an easier one later on, right? With practice, that doesn't take long. It doesn't, but, oh, it requires practice. Ha, 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 ha. Okay, 2 more techniques.
Oh,
For our next trick, because I'm teaching you all my tricks, we're going to do subtle substitution. And it's not so subtle anymore. Y'all don't do subtle. Subtle substitution, and the best way I can show you this is to actually do it. So, if we integrate 1 over e to the x plus e to the negative x dx. You can't do u sub because the derivative's not up top. I am going to rewrite this as the integral of 1 over e to the x plus 1 over e to the x dx. I want to clear out that denominator. It bothers me. I can't do anything with this. So I'm going to multiply by e to the x over e to the x. Did I just multiply by 1? Remember, we've been doing this for a while now. So what's that equal? That equals the integral of e to the x over, well, if I multiply this, this is going to be e to the 2x. And then that, when I multiply, is plus 1 dx. Do we agree? Wait.
Yes.
Can I rewrite this another way? Watch what else I can do. I can rewrite this. Can I rewrite that as e to the x squared?
Oh.
If I write it that way, can I do a u sub? And is it inverse trick? It really is. All right, so looking at this, that's a equals 1. This is u equals e to the x. What does du equal? E to the x dx. This is very hard for y'all to see. That's du. It's really hard to see unless you will actually, anytime you see something, you end up with a squared plus another squared down in the denominator. You should think inverse trig. Even, you gotta make sure, the whole trick here is because derivative of e to the x is e to the x. That's why this works. So when we do this, what is it going to equal? Hang on, let me change colors. It equals, what's the a? 1, so 1 over 1 is just 1, so it's tangent inverse of, what was my u? E to the x. What was my a? 1, so it's just e to the x, right? Plus c. Tricky. Y'all can pass the panic sequence.
Initiating panic sequence.
It's easy if you see it, but you gotta see it. That's why it's considered subtle. It's very subtle. All right, let me see if I have enough room for the last one. I don't think so. I think I need to add a page. Okay, for my last one. If you were in my class, in Algebra 2, I talked about the conjugate method. I called it that. It's when you multiply by, so you have a difference or a sum, and you multiply by the difference or sum to clear something out that you don't want, that you can't handle, like square roots. But we can use it for all kinds of interesting things. We used it back when we did limits at the very beginning of the year. Remember that? Oh, yeah, we did. So, conjugate method. Just think of this as like a toolbox. I'm adding more tools into your toolbox. We have 1 over 1 minus cosine of x dx. You can't integrate it because the derivative of cosine isn't up above. You can't use u subs. Blech. You can't use u sub, can you? Nope. So here's what we're going to do. I'm going to move my dx out to the outside over here. And I'm going to multiply by 1. My favorite number when I'm doing this kind of stuff, but I'm going to multiply in 1 in the form of the conjugate. It's going to be 1 plus cosine of x, 1 plus cosine of x. Do we all agree that if we multiply by 1 plus cosine of x, the middle term goes away? The cosine of x goes away. Am I going to end up with a square? So what do I end up with? I end up with the integral of 1 plus cosine of x over 1 minus cosine squared of x dx. Wait a minute. What is 1 minus cosine squared of x? Sine squared of x. It is. So this becomes the integral of 1 plus cosine of x over sine squared of x dx. Still not there yet. I got to do one more little subtle thing. Can I break this into two fractions? Been doing that to you for a while. Becomes 1 over sine squared x dx plus the integral. I'm breaking it into two because they're different techniques, aren't they? I'm going to have to do different things to each part. What is 1 over sine? So this becomes the integral of cosecant squared of x dx, which is easy if you memorized it and not so much if you haven't. Remember the sign mistakes. Okay, for the other one, do I want to do a u sub? I do. For this one, I'm going to make u equal to sine of x, du equals what? No, not negative. Cosine of x. I'm doing derivatives. dx, right? So is this the whole thing du? So when I do my substitution, it becomes the integral of 1 over u squared du. Is that easy to integrate? It is. It actually is, and that's really straightforward now. Okay, so what is the antiderivative of a positive cosecant squared of x? A negative cotangent of x. Remember that? If you do an antiderivative and it starts with a c, either it or the thing you were integrating has to be negative. Since that was positive, the answer has to be negative. Okay, can I rewrite this as u to the negative 1 or negative 2 power, right? So do power rule in reverse. What is this going to equal? Plus, what's my new power?
U negative 1.
Over negative 1, and this is plus c. That means this is going to be a negative cotangent of x minus 1 over, what was my u? Sine of x plus c. That was fun. Okay, so it's taking everything you've already learned about integrals so far, and we're adding in some algebra 2 stuff and some algebra stuff we learned for limits to manipulate the the derivative so that we can get an antiderivative. Tomorrow we begin integration by parts. That's ultraviolet voodoo. You think You think it's been magic so far? Wait till tomorrow. We get to pull up.